Welcome back to your computer application class 7. In this part of the video, we will continue the topic. That is chapter number 3, number system and introduction. So let's begin. As we had learned in our last video that computer is an electronic machine and it works on the only two discrete values 0 and 1. 0 represents off and 1 represents on, which means that 0 is the absence of pulse and 1 represents the presence of pulse. Number system is a way to represent numbers in a computer system. Every value that you are getting from a computer system has a defined number system. Mostly we have two types of number system. One is non-positional number system and second is positional number system. Right. Non-positional number system mostly used in mathematics. Let's go through the book contents and then our concept will be more clear. In the past, human beings counted on finger. For counting beyond 10, they used stone, pebbles and sticks to indicate values. This method of counting used additive approach or non-positional number systems. Like for 1, 1, 2 for 2, 3 for 3, 4 for 4 values. So these methods mostly we had used in our younger age when we have to count the values like 1 plus 2 plus 3. Then how we mostly perform the calculation? First we draw the 1 line, then 2 lines and then 3 lines. And we counted like 1, 2, 3, 4, 5, 6 and the answer is 6. That is basically your non-positional number system. In a non-positional number system, either we use lines or the different scenarios to count the values. Each symbol represents the same value regardless of its position in a number. And to find the value of the number, one has to count the number of symbols present in the number. It is very difficult to perform long calculations by using this procedure. Next type of number system which we have, positional number system. This number system we mostly use in the computers to store data and also to perform calculation. Let's go through positional number system. In a positional number system, we have a very few symbols which termed as digits. These symbols represent different values depending on the position they occupy in a number. The computer understands positional number system to store data and also to perform calculation. Mostly we have 4 types of positional number system. One is a decimal number system, second is a binary number system, third is octal number system and fourth is hexadecimal number system. The base of decimal number system is 10, base of binary number system is 2, the base of octal number system is 8 and the base of hexadecimal number system is 16. Let's go through in detail. Decimal number system base is 10 number system. The reason is that they had used 10 symbols. Varies from 0 to 9. Each symbol in the number system has a value associated with it. For example, 3 represent the quantity of 3 and 5 represent the quantity of 5. 7 represent the quantity of 7 and 2 represent the quantity of 2. When we have long decimal number system, then the position of number system depends on their location. For example, let's take the example of 123. Here, 3 represents 1, 2 represents 10 and 1 represents 100. Here the example is given according to the decimal number system. The number 123 is a sum of the values in each position of the numbers. So this is our ones, this is our tens, this is our 100. 100 plus 20 plus 3. The total will be 123. Let's see how they had represented. The same as it is. 1 into 100 plus 2 into 10 plus 3 into 1. 10 raised to power 2, 10 raised to power 1 and 10 raised to power 0. Next number system is a binary number system. Binary number system base, as we had discussed, is 2. The reason is because binary number system uses only 2 symbols, that is 0 and 1. In a binary, the place value moving from right to left are successive powers of 2. To construct a binary number, place ones in the position where the corresponding values add up to the quantity you want to represent and place zeros in the other position. For example, Here we have the 4-digit binary number system, that is 1248, and according to it we will work from right to left. For example, the value is 1001. So we will use the same scenario which we had used in the decimal number system. Each value will be multiplied by its base value while raising, and afterward we will raise their powers. So 1 into 2, because the base value of binary is 2. So 1 into 2 plus 0 into 2 plus 0 into 2 plus 1 into 2. And afterward we had said its raising powers, that is 0, 1, 2, 3. 2 raised to power 0. Here the answer will be 1. 2 raised to power 1, that is 2. 2 multiplied by 0, 0. 2 raised to power 2, 4. Multiplied by 0, that will be 0. 2 raised to power 8 multiplied by 1 is 8. So when we will add these values, the value which we receive, that is 9. 9 is a decimal number of 1001. Or we can also say that the binary representation of 9 is 1001. We can also consider the table which represents binary number system as well as the decimal number system. Next we have octal number system. The base value of octal number system is 8 because it represents 8 symbols. That is 0, 1, 2, 3, 4, 5, 6 and 7. The largest single digit is 7, and each position in an octal number system represents the power of base 8. Here the example is given 112. The same scenario is followed here. 1 into 8 plus 1 into 8 plus 2 into 8. And afterward they had said the values 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. 8 raised to power 0, that is 1. So 1 into 2, the answer will be 2. 8 raised to power 1, 8. 8 multiplied 1, the answer will be 8. 8 raised to power 2, 64. 64 multiplied 1, the answer will be 64. So 64 plus 8 plus 2, that is 74. In that case, we can say that the decimal equivalent of octal number system 112 is equal to 74. Same scenario we will follow in hexadecimal number system. Now, as we know that the hexadecimal number system base is 16. So it means that it will represent 16 characters, 0 to 9 symbols, and capital A to capital F letters we will use. It can represent binary values in more compact and readable form. The conversion between the binary and the hexadecimal number system is very efficient. Here we will take the base of 16. So let's consider if we have the value 1FF as a decimal equivalent of hexadecimal, then how we can sort it out? Well, we can use it, the hexadecimal base 16. For solving it, 1 into 16 plus f into 16 plus f into 16. 16 raised to power 0, 16 raised to power 1, 16 raised to power 2. F represents value 15. So in that case, 15 into 1, 15 into 16, because 16 raised to power 1. So the answer is 16. 15 into 16. 16 raised to power 2 is 256. 256 multiplied by 1. When we will add all these values, then we will get the output 511. So the decimal equivalent of hexadecimal 1FF is 511. I hope the concept of number system and the different types of number system is clear for all of you. If you have any query, please feel free to ask in your online classes. In the next part of the video, we will learn about the conversions. That's all in this part of the video. Thank you.